Hello everyone, I am Krutika S Lakkannavar and I welcome you all for the B.Sc second semester mathematics classes. So in this particular video, I am going to start with the topic that is reduction formulae. So first, it is necessary for us to understand what are these reduction formulas and where we use them. So firstly, whenever we will consider some functions, particularly if we consider the trigonometric functions with the higher degrees. For example, you can take sin raised to 7x or cos raised to 10x. Yes, if suppose these functions we will take and we want to get their integration. Yes, you can take that. The integration we feel like it is somewhat difficult. Okay, to get those values of the integration it is somewhat difficult as compared to the other functions with the lower degree. So in such type of functions, means the functions with the higher degree is there, no, to solve these integrals we will use the reduction formulae. And these reduction formulae connects, okay, these reduction formulae connects the integral of higher degree. Okay, integral of higher degree with the same type of function, that is integral of the same type with the lower degree. Means we will consider the integration of the function of the higher degree, and here reduction formulae connects integration of the same type. Means if we have taken here integration of sine, that will connect the integration of sine itself but with respect to lower degree. Means sine raised to, if we have taken the 10, that reduction formulae what they do is they will give a connection to the integration of function sine itself but with respect to the lower degree, that is less than 10 we can take. Okay, so these reduction formulae we can use not only for the power 10. Okay, you can take any power to the any trigonometric function or other functions also, so that to get the integrals easily. Yes, here we will take the reduction formulae which are the part of integral calculus. These helps us to get the integrals of the particular functions, or you can take some functions with the higher degree. Okay, that is about the reduction formulae. So this is about the small concept about reduction formulae. Next we will take the reduction formulae of particular functions. Firstly we will take the trigonometric functions. That is the reduction formulae of the 6 trigonometric functions. Okay, sine, cos, tan and their respective inverses. For all those we will find reduction formulae. So first reduction formulae I will consider with respect to the sine. Okay, that is integration of sine raised to nx into dx. So this is our first reduction formulae. Whatever the reduction formulae here we are going to find, that reduction formulae you can use integration of the sine raised to n, means for any power of sine, it may be 10, it may be 20, okay, or it may be any other greater number. So that value we will find here, and that formulas again we can take for the powers of sine, that is integration of the function sine with respect to the any power you can take. Yes, let us take this integration. Yes, to integrate this we will use the integration by parts. And how to get that, or whenever you will take the integration by parts, there must you need two functions. Okay, this function itself I will take it in the product of two terms. Let us see how to get that. First, I will consider this given integral as in. So in is equal to integration of sine raised to nx into dx. This sine raised to power n is there, no? That I will convert in the form of product of two terms as integration of sine raised to n minus 1 into x again into sine x into dx. Yes, if we have applied here the properties of indices, that is sine is there, then you can add the powers, again you will get the n. So here what we will do is, I will consider here this as the first function and this sine x as the second function, and now we will apply the integration by parts. Okay, so let us have that. Therefore in is equal to, okay, first function as it is, that is sine raised to n minus 1 into x Then integration of second function, that is integration of sine is, we know that it is minus cos x. Then minus integration of, you have to take here now differentiation of this first function. So sine raised to n minus 1 x differentiation is n minus 1 into sine raised to n minus 2 x, and again into sine x differentiation you have to write. So sine x differentiation is, it is cos x. Then again into integration of second function, that is again cos x minus cos x, and this integration dx as it is. Now here, so plus into minus is there, in total I will write it as minus sine raised to n minus 1x cos x, then minus, see here one more minus sign is there inside, so that I will take outside, it will be plus. Then again this is the constant term, so I will write it outside n minus 1, then remaining is integration of sine raised to n minus 2x. Here cos x is there, again cos x is there, so cos into cos I can write it as the cos square x into dx. So this is our IN. In the next step, what I will do is here, this cos square I will convert in the form of function of sine, and that I will multiply inside. Okay, let us see how to get that, and writing all the other terms as it is. So here we will get IN is equal to minus sine raised to n minus 1x into cos x, this is as it is, then plus n minus 1 also as it is, integration of sine raised to n minus 2x. Now this cos square you can write as 1 minus sine square x. Okay, this we know that cos square you can write as 1 minus sine square, that I have written. And in the next step I will multiply this integration term to the both of these terms. Okay, so what we will get is that minus sine raised to n minus 1x cos x plus n minus 1 into, okay, here I will consider separate bracket, that is because of two terms, right, and n minus 1 is multiplication for both the terms, hence I will write here bracket, that integration of sine raised to n minus 2x into 1 is there, so it is integration of sine raised to n minus 2x into dx. Then here it is with respect to the plus, and that is with minus, so plus into minus is minus integration of, see here, sine raised to n minus 2x into sine square x. Again it will comes again, yes, bases are same means you have to add the powers. So n minus 2 plus 2, that is plus 2 and minus 2 get cancels, for the power, yes, that is for the sine, power will be remaining as only n, and into dx, here complete the bracket. Okay, so minus sine raised to n minus 1 x cos x plus, now multiply this n minus 1 inside, and observe here IN is equal to what? Sine raised to n is there, means there we will get here sine raised to n minus 2. Yes, according to this, what I can write it as IN minus 2, and similarly here this is nothing but our IN. Okay, let us observe here how I am writing that n minus 1. First I will write the separate terms, then you can substitute that one, x dx minus n minus 1 into integration of sine raised to nx into dx. Okay, so it is equal to minus sine raised to n minus 1 x into cos x plus n minus 1. Okay, as I have told you, IN is equal to sine to the power n. So means whatever the power for sine is there, that here we will consider the suffix. So it is IN. Similar way, here power is n minus 2, means I have to write it as IN minus 2. Then minus n minus 1 as it is, and it is nothing but our IN. That is our consideration we have taken. And this side again it is IN. Yes, now it is IN is there, and this term is also IN is there. Take this one to this side and other terms as it is. That is IN, that is with minus sign. So here it will be plus n minus 1 into IN is equal to minus sine raised to n minus 1 into x cos x plus n minus 1 into in minus 2. Then here if you have taken in as common, remaining is what? 1. Yes, here it is 1 plus n minus 1 will be remaining. Then 1 and 1 get cancels, only it is n. That I can write as n into in. Okay, this is the simplified term of this one. So n into in is equal to this term as it is, minus sin raised to n minus 1 into x cos x plus n minus 1 into in minus 2. Now this is our required reduction formulae, or else if you want to take it in the form of integration of sine, I can write this as, and again here in is equal to integration of sine I will take, and this n I will take it to the other side. Therefore I can write here integration of sine raised to nx into dx is equal to, yes, addition of two terms is there, means n you have to take divided as for both the terms. So minus sine raised to n minus 1x into cos x divided by n, then plus n minus 1 divided by n in minus 2 is integration of sine raised to n minus 2 into x dx. So this is our required reduction formula of sine raised to nx dx. Okay, or you can take reduction formula of sine raised to nx. So whenever in the example, if suppose sine raised to power any power if it is given, we can use this formula and we can get its integration within minimum steps. So this formula you have to be remember. Okay, this formula is important for you to solve the examples where it is asked the sine power as larger number. Okay, and here you can take n belongs to positive integers. Yes, this is about the reduction formulae of sine raised to n, and in the next video again similarly we will prove about the cos. Yes, and again we will take examples also on this one, that is sine raised to power 3, or you can take sine raised to 4. Yes, like this powers we will consider and we will solve the examples. Okay, thank you.